It is with great pleasure that I welcome my first guest to the stage, Professor Miomir Knežević.
So, buongiorno.
For decades, aging was considered an inevitable and irreversible process. Today, advances in longevity science, regenerative medicine, and cellular biology are challenging this assumption. Professor Miomir Knežević will help us explore one of the most provocative questions in modern medicine. Can aging itself become a treatable biological condition? Professor Knežević, for centuries, aging has been viewed as a natural and unavoidable process. Do you believe that we are approaching a moment in medical history where aging itself may become a treatable biological condition?
Thank you for this question. I will disappoint you with the answer because the thing is that this is very optimistic, but the trends are going in direction at least to slow it down or make it, let's say, acceptable. So we are all talking about healthy aging, and we all want, let's say, to live our life functional. And because our body consists of the cells, cells are quite important. How we make them environment, how we feed them, how we treat them, how we mistreat them, this is all seen in our body. Skin is first, but inner problems are bigger. One of the biggest challenges for aging is immuno-aging, because when you compare primates and humans, humans are living longer because of the strong immune system. But on the other side, this strong immune system provokes inflammation. And it gives also a very, let's say, I would say, hard impacts on our life once we are, let's say, older than 22 years. Because that's the time when our damages are becoming bigger than repair.
Exactly. Thank you so much for that. One of the most exciting developments in longevity science is our growing understanding of cellular senescence. Are senescent cells simply markers of aging, or are they active drivers of biological decline and frailty?
Yes, senescence is something which we would like to tackle, and it's a natural concept which gives signals for, let's say, for repair or switching off the clock and so on. And it is one of the keys where you not only mark it, but you also would like to, let's say, get rid of it. And in animal studies show quite good results in it and promising results, but we cannot, let's say, repeat it in humans to this extent, because most probably it's more complicated to do it systemically in humans. And partially, let's say, we can use antibodies to get rid of the senescent cells, because senescent cells are giving signals to all other cells what to do, and this helps. We would like to use more easy therapies, not so aggressive ones. Let's say when we are using also some food supplements, healthy lifestyle, and everything else to have the similar effect.
Excellent, grazie. Senolytic therapies and emerging anti-aging vaccines are generating enormous scientific interest worldwide. How realistic is the prospect of selectively targeting senescent cells to extend health span in humans?
Yes, that was exactly, let's say, just continue with my previous information.
Yeah.
So thank you for the question.
There you
That's exactly what we are trying to do. As I said, animal studies show this quite effectively, or let's say at least promising signals, but in humans we still do not achieve this effect. So I would say probably better antibodies or better approaches how to destroy the senescent cells or deactivate them. This is a challenge for the science first in the research and development, and then find let's say, treatments which can be with no harm used as a prevention of aging or biological aging.
Very interesting point, thank you. Frailty remains one of the greatest challenges of aging societies. Should frailty be considered an inevitable consequence of aging, do you think, or a biological process that can potentially be prevented and reversed?
Reverse is still too optimistic. Let's say slowing down, it's something which I would say it is realistic. Stopping it completely, it's very optimistic still, but let's say we will go in that direction because this is, let's say, aging is like multifactorial disease. Exactly. You cannot treat just one point, or let's say use a drug, because our body does not consist of drugs, but we consist of cells. And this cell communication is important. It depends on the cell and the stage of development of the cell. On the other side, it's about the environment where it is, and also the damages which are there in their genome, how to express then all the proteins, all the enzymes which are there. And let's say at a certain moment, if such cell is, let's say, corrupted before, then it has to go to apoptosis and die. So important part is also that we prevent our stem cells, which we have in our body, and which are supporting our organism to let's say, to regenerate. It's not just heal, but regenerate. So it means that you have functional cells. It's very different from brain, when you need years to, let's say, replace the cells which are there, to the, let's say, skin or epithelia, when it happens in 14 days. There are also parts of our body which totally, they do not change during their lifespan. Once you, after conception, and especially those linked with the visual, let's say, the neurons in the visual cortex, these are defined, let's say, when you are born and so on. So it's very, very, very different. And for each of them, we have to use different approaches.
Grazie. Stem cell therapies and regenerative medicine are increasingly being explored as tools to both restore function and resilience. Do you believe regenerative medicine will become one of the central pillars of the future of longevity medicine?
Yes, I'm convinced. When I started with the field in 1995, we started with ACI, autologous chondrocyte implantation, and paradigm was in the university that cartilage is not regenerating. So the paradigm was broken at that time, and that was quite important. Yeah. And this will, let's say, continue, and there were big promises, sometimes over-promising, but the field was called tissue engineering. Then we were doing the same, and it was called regenerative medicine, then stem cell medicine. Now it's longevity or healthy aging, but we still are doing similar things. And we all go in this direction, how to, let's say, make our life more acceptable, and that we stay functional for a longer time. So regenerative medicine is important here.
Higher quality.
Yeah, and quality, of course. But
Always.
if you are just, let's say, staying somewhere, let's say, deeply depressed, you cannot move. You have big house, but you cannot walk, to come to the toilet in the next. That's like, let's say, running, driving Formula One. We are here in Lamborghini Museum. Is for one, let's say, 90-year-old person who cannot move, going in the evening or during the night to the toilet. It's like, a race for Formula One.
Exactly. Thank you. Much of medicine still relies heavily on chronological age. Do you think that we're moving toward a future where biological age and aging biomarkers are becoming more clinically relevant than the number of years that a patient has lived?
Yes, of course. This I cannot agree more with what you say. And when we will talk about aging, we won't absolutely talk about chronological aging. It is more for bureaucracy. The aging which is important is biological aging.
Thank you. Looking ahead 10 years, which scientific breakthrough has the greatest potential to transform the way physicians understand and manage aging?
The things are that there will be more, not just one, because all scientific, you cannot predict scientific breakthroughs. They happen, and this is not predictable. But there will be a lot of them which, like, let's say, in cell therapies, these were first IPS, induced pluripotent stem cells, were something which were big step ahead in 2006. Yamanaka and the researchers. Then it was for cell therapy, it was CAR T cells for cancer therapy. They boost the cell therapy. And at the same time also opened the door for other, let's say, mesenchymal stem cell usage, especially in immunomodulation. So it means now I think the biggest success will go in controlling inflammation. Yeah. With this, we can get a lot of, let's say, benefit for the patients in this period of time which you mentioned.
Exactly right. If there's one paradigm that physicians attending Life Scientia Vitalis 2026 should remember regarding aging research and longevity medicine, what would be your key message?
My key message would be, before I spoke with my colleagues, with Mariam, was that you have young cells and you have the proper environment. We realize that regenerative medicine, let's say, is working not so good exactly when you need it. It means after 45. We all know that you have these two peaks of the aging at 45 and 65.
Oh, interesting.
And if you can, let's say, move these shifts and or shift them and so on, this could be then a big success.
65 and 85?
Yep, that would be something, I would say. We have to go, let's say, in steps, and we should be happy that many people can achieve this, let's say, all around the world. And differences are incredible because you have, let's say, people who are 100 years old also in our history, but not many. You know, average in our country, in Slovenia, 160 years ago, average age was 38 years.
Wow.
So, and now it's 80, 82.
We've made a lot of progress.
Yeah,
and now, Professor Knežević, the future of longevity medicine may not depend on one single therapy, but on our ability to understand and modify the biological mechanisms that drive aging itself. The ultimate goal is not simply extending lifespan, but preserving function, resilience, and quality of life throughout aging. Grazie mille for all of your contributions.
Thank you very much, Jessica.
Thank you so much.